Welcome back to our series of lectures. Lesson 5.2 will be solving absolute value equations using the definition of absolute value. But before we use the definition of absolute value, we can try to find out these trivial cases solutions. Okay, for example, absolute value of x minus 5 equals 0 is considered trivial, meaning your solution can just be guessed. Okay, it's quite simple enough. It's quite absolute. Erase that. When we mean trivial case, it's simple enough that you can guess the answer. So what will make the left-hand side 0? This one is equal to 5. So my solution to this will be equal to 5. Now, what about this one here? This is another trivial case. The absolute value of an expression can never be equated to a negative number. So there is no value of x that will make the left-hand side be equal to a negative number. So, this one now, the solution set will be a null set. We won't be interested with these trivial cases. What we want to have will be, for example, what will be the absolute value of x minus 3 equals 5? What will be the solution to that? Okay, using the definition of absolute value, we have to redefine this. We know that absolute value of x minus 3 will be itself x minus 3 or negative of itself. Okay, when will this be equal to itself? If the number is positive or 0. And when will it be negative of itself? If the number is less than 0. Okay, so therefore we have to consider two cases here. Now, case 1 will be, suppose we have x minus 3 greater than or equal to 0. That means the number is positive. Then, this implies that its absolute value will be itself. So we get here x minus 3. And this is equal to 5. Remember, 5 here is a constant. So this one should not be changed in our redefining this absolute value expression. So we are going to solve this x greater or equal to 3. Intersection, this one here, x equals 8. If you will notice, x greater or equal to 3 is going to the right and it will pass through x equals 8. So the intersection should be x equals 8. Or we get case 2 here. Suppose this number is negative. If this number is negative, then its absolute value is the negative of itself. So the negative of itself equals 5. Again, this one is not touched. It's constant there. And we will solve for this. This will be x less than 3. Intersection. This will, I can multiply everything by negative. So the negative transfers here. So I will get here x minus 3 equals negative 5 or x equals negative 2. Now, this is going to the left and it will pass through negative 2. So the intersection of this inequality and this equation is this one here. Therefore, your solution will be case 1 union case 2. Or this gives me 8 or negative 2. You can easily check your answer. 8 minus 3 is 5. Absolute value of 5 is 5. What about negative 2? Negative 2 plus negative 3 is negative 5. Absolute value of negative 5 is 5. So, we are done. The solution to this equation is 8 and or negative 2. Let's have another example. Suppose we have this 2x minus 5 equals 4 minus x. Again, we will redefine this expression as what? 2x minus 5 equals itself if the number is greater or equal to 0, or negative of itself if this number here is less than 0. So this will take our case 1 and that one our case 2. So we get here, remember, this one is not touched. Only this one is being redefined. Okay, so case 1 here will be, suppose this one is greater than or equal to 0 here. Then the absolute value will be itself. Then this implies that its absolute value is itself equals 4 minus x. Or case 2 here, suppose the other case is the number is negative. So if the number is negative, its absolute value is the negative of itself equals 4 minus x. And then we will solve this inequality. This is 2x greater than or equal to 5, or x greater than or equal to 5 over 2. Intersection. Minus x comes here, we get 3x, and negative 5 goes to the other side, become a 9. Then this one will now be x equals 3. This is 2.5 going to the right, so it will pass through x equals 3, so that's the intersection. And this will give me 2.5 going to the left, and I can solve this equation here. I will get here 4 minus x. I will transfer negative 2x to the other side. So we'll have 2x minus x will give me x. So 5 minus 4 is 1. And this one will pass through this. So this will be the solution. So your solution set will be 1 or 3. Let's see. If x is 1, 2 times 1 is 2, minus 5 is negative 3. Absolute value of negative 3 is 3. 4 minus 1 is also 3. So this is correct. What about 3? 2 times 3 is 6, minus 5 is 1. 4 minus 3 is also 1. So both of these are solutions to this equation. Okay, let's have another example. Example number 3. Suppose we have absolute value of 2 minus 3x equals absolute value of 4x plus 1. Okay. Now, we will use another form of the definition of this absolute value. Remember when you were in the lower years, this absolute value of x here is actually square root of x squared. So, I can actually rewrite this absolute value here by saying that will be square root of 2 minus 3x squared. And similarly, I can have this as 4x plus 1 squared. Now, I will not cancel the index here because doing that will be losing a root. Okay, so what I'll do is, I will solve this as we are solving a radical equation. I want to remove the index, so I will square both sides of the equation and I will get here what? 2 minus 3x squared equals 4x plus 1 squared. Now, I don't need to expand this, I don't need to expand that. Instead, I am going to treat this as a difference of 2 squares by transferring this to the other side. Now, this is a difference of 2 squares. I can now factor. Okay, and I will have here 2 minus 3x plus 4x plus 1. And the other one here is 2 minus 3x minus 4x plus 1. Simplifying this, I will get 2 plus 1 is 3. Minus 3x plus 4x is plus x. Here, I will get 2 minus 3x minus 4x minus 1. Or this will give me minus 7x plus 1 equals 0. Using the zero product theorem, I will get here x equals negative 3 or x equals 1 over 7. And I can easily show that negative 3 and 1 over 7 will satisfy the given absolute value equation. Okay, let's have the last number there. Absolute value of y squared minus 3y equals minus 4y plus 6. Minus 4y plus 6. Okay. Y squared minus. Okay. Now, again, we will redefine this. Y squared minus 3y can be this number itself if this number is positive or 0 or negative of itself if this same number here is less than 0. Okay? So, case 1 here will be, suppose this is positive, y squared minus 3y greater or equal to 0. This implies that, again, I'm saying that this one will not be touched. Okay? It's only this one that we will be rewriting. If this number is greater or equal to 0, the absolute value should be itself. No change. And then this is negative 4y plus 6. And case 2 here will be, suppose y squared minus 3y is negative. Then the absolute value is the negative of itself. Equals minus 4y plus 6. Now we will solve this. This inequality is a greater than inequality. So, the best way to do this is to solve using critical numbers. My critical numbers are 0 and 3, and this is a greater than inequality. Therefore, it goes to the left or to the right. So, the solution to that will be less than or equal to 0 or greater than or equal to 3. Now, let's find out. We will intersect it with the solution of this equation here. Y squared plus y minus 6 equals 0. And this is factorable. I will get two values, negative 3 or 2. Now, let's look at negative 3 or 2 if they are in this interval. This interval, let's say this interval, intersection, this one here, what will be the intersection? This is negative 3. Now, this interval, intersection these two, there's no intersection. So, there's only one solution that satisfies case 1. Now, what about this one? We solve this inequality. Again, the critical number is 0 and 3. This is a strict inequality. We are solving a less than. So, therefore, this should be the solution. And we are going to intersect it with whatever this solution here is. I can multiply this now by negative. So, I'll get that. I will transfer this to the other side. So, 4y minus 6 equals 0. Or I will get here minus y squared plus 7y minus 6 equals 0. It will be more convenient for me to make the coefficient of y squared positive. So, I'll multiply the whole equation by negative 1. So, I'll get y squared minus 7y plus 6 equals 0. And this happens to be factorable. So, you get y minus 6, y minus 1. So, y equals 6 or y equals 1. Now, let's see. If we intersect this interval, 0, 3, and this one, there's no intersection. But 0, 3, and that one has this as an intersection. Therefore, our solution to this inequality will only be what? Negative 3 or 1 there. You can check it. If y is negative 3, this is positive 9. Negative 10 and negative 3 is positive 9. So this will be 18 minus 4 times negative 3 is 12 plus 6 is also 18. So that's correct. What about 1? 1 minus 3 is negative 2. absolute value is 2. Minus 4 times 1 is minus 4 plus 6 is also 2. So both of these are solutions. There you go. We have solved absolute value equations using the definition of absolute value.